This is the continuation of the previous video. In the last video I showed you how to use SRI4X using PN532, and in this video I'm going to show you how to use SRI512 tag using PN532. And in the last video I also mentioned that I've already made few videos on SRI512 tags, and in this video I'll be repeating a little bit. Plus we also introduced a new feature in the SRI4X screen, so that I'm going to explain in detail in this video. I'm going to place the SRI512 tag, which here it came as a sticker, but I have got it on a plastic card. So when you have a sticker on a card, so you have to keep in mind that the sticker, the card sometimes never get recognized. So I'm going to show that now. So here it's fine. Sometimes you will get an error. So if you come across an error, you just have to try to find a right place for the tag. Or sometimes also it is also good if you can reverse it and keep the sticker close to the PN532. Now I did mention in the last video about the state transition diagram of the SRI tag. So I'm going to show you this diagram in the screen. Now we are, as soon as the tag is placed, the tag is already in the ready state, and it also has produced a unique chip ID. Now when you hit that activate button on the screen, the tag is already in the ready state. It is sorry, in the selected state. It's over here. Now I'm going to remove this tag and just follow this diagram one at a time. So I'm going to place it. Now we know the tag is in the ready state, and I'm going to take it to the inventory state by issuing a initiate command. So initiate command. So this generates, or this command responds with the chip ID 9C. So we are here. While in this state, I can issue any number of initiate commands. The pcode 16 and slot marker, I have explained this in my video using a different reader writer, that's CR95HF. So I can keep on issuing the initiate command, so the tag will still be on the inventory state. Now this is nice to see here, you get random numbers. Now the chip ID of this tag now is ED. Now from here I have to issue a select and the chip ID to get the tag to selected state. So I'm going to hit this select button. Now the select button, if you see, the parameter sent is ED, the chip ID, and soon after that, in fact the documentation says the response from the select command should match the chip ID. So when these two matched, the select is right. Otherwise probably we ended up selecting a different tag. As soon as that, the software issues a get UID, and the reason this is done is to know what type of tag is it, whether it's SRI4X or 512. To know more about get UID, if you hit this system tab and hit this get UID, and this is how the 64-bit is decoded, and this is 03 for SRI4X and 06 for SRI512. So I'm going to try. So what I'm going to do next is, so click on a read. So somehow the read is not right. You can see something has happened after the block number 10. Now it's because of the way I placed the tag. So try again. I'm going to click on initiate and select and click on a read. Okay, so now we have read all the 16 blocks plus the system block. Now I'm going to send this deselect this tag. So if you look at this state diagram, there is no deselect command. You just have to select with a different chip ID. So we are taking this tag on here to the deselected state, and I'm going to select bring one more tag from ready inventory to selected state. Now the chip ID is 9B. Deselect, I'm just sending a different chip ID, that's 9C. If you try to read, just hit on a read here. So we get error message because while in the deselected state we cannot issue any other command other than just a select. So compare this with the selected state where we can send all these commands: select, read and write block and get UID. So that was 8B, you remember that. I'm going to place a different tag above that and give initiate. It's a 74. Select, I'm selecting the second tag and hit the read tag. Now this time we have read a different tag altogether, and I'm going to send this tag to inventory, and while in inventory again you cannot send any read and write command. Just give it a try to read block number 10, you get error message. So I'm going to select our first tag, which was a chip ID 9B. I'm going to say select, got selected, and read. So something wrong here, probably something wrong in the way I placed the tag. So there's one thing I've noticed with this SRI sticker tags. These stickers work very well if you just hold the sticker right on this. Okay, so explain this how this multi-tag operates in my previous video. Now this tag has already got so many blocks that are locked, and we have seen previous video the lock bits are present in the block number 255, which is here. And since we are using SRI512, so in SRI512 all these 16 blocks are lockable. So if you compare this with SRI4K, in the 4K we had OTP and we had 5 OTPs, counter, 2 counters, and from block 7 to 15 was the lockable user data, whereas in SRI512 all these 16 blocks are lockable. Even the counters are lockable and OTP are lockable. If you try to write, I'm going to go to OTP and try to change this OTP, and keep in mind we are trying to write to a block that is locked, and many people have asked whether is it possible to unlock a block. I would say that will be impossible. So just don't expect anyone to unlock a locked byte. Now this is done for security, and once the block is locked, it's completely locked forever. Now I'm going to write. If you hit a write button here, so you will get the OTP 0 write error. So if you look at the commands that are sent, the data that we sent for write did not match the data that we read back. So that's thought you keep in mind, the locked block cannot be written. Likewise, I have got the block 5, which is the counter, that's also locked, and if I try to change or decrement the lock and give a write, you get the read after write did not match. So block 5, the write operation failed. Now if you want to lock, so I can show you how to lock, say for example the block 8. If you go to system, and this is where and if you compare this screen with the SRI4K, SRI4K had only 8 log bits, whereas here you got 16. Now I want to log, maybe before we log, assume that most often we do write some data here. I'm going to write 41, 42, 43, 44, and issue a write command for block 8. I'm going to have a write command. So write is successful. Once the write is done, probably we would like to lock it. I'm going to put a tick and say write. So now we have locked this block forever. And again, there's a message here. I might have got this message from the documentation. It says the system block write OK effective only after reactivation. The sense, even though the screen shows the block is locked, so I can still go and modify, set this as 44, 45, 46 or 47 or 48. If I try to write, you can see the write is still OK. So lock will be effective only when reactivated. We can either do by hitting this complete. Now if you look at the documentation, so if I issue a complete tag, the tag goes to deactivated state, and the only way, there's only one arrow going out from this state, that is out of the field. Take it out and bring it back. This time you don't have to go through the activate command because the PN532 is already configured to use the type B tag. I can start with the initiate. You got this time you got the chip ID EE. Select and click on read. You can see that the data here. So it didn't the data was already present. I'm going to close this. Try again. Initiate. So there is no response here because of the way I have placed the tag. So just move a little bit. Oh, maybe the first time I think you have to issue this. I was wrong. Okay, you can see that it's we wrote 44, 45, 46 and 48. So now it's in lock state. Now also if you look at the grid here, all these unlocked grid rows are editable, whereas when you click on this row which is locked, you can't edit it. Okay, that's something the software has done it. So next I would like to show you one more feature added in this version. It's called offline version. So what it means is, if you look at these write buttons, as soon as you hit the button, the data is sent to the tag. So it's not only here. If you go to the OTP, as soon as the write button, the data get copied to the tag, and counter as well. Now when this offline is ticked, all this write button now shows as save button. Now what it does is, now whenever hit this button, the data is copied from the user interface to the grid. It is not transferred to the block. And eventually if you go to the offline tab, and this section here lets you copy the selected blocks to the tag, and when you do that, you can choose whether to start with the array cycle and whether to copy the to the page to block 255, which is the log page. It's supposed to be a block. The page is something we use in MIFARE tags. In these type of SRI tags, and it's all called a block. Okay, so this is just offline. You can play with the grid data. Once you're happy with that, you can send this choose the block numbers and write. So I'm going to play with the OTP. Now I'm going to put a tick here, go to and click on a save. You can see that the data is just copied here and nothing has gone, no commands you can see here. That shows no data is returned to the tag. Now I'm also going to play with the some data bits here. 0. Now I'm going to say 41, 42, 43, 44, and I'm going to write now say 10, 11, 13 and 14. So you can copy anything, if you want to copy a number, you can click on block 11 and you see the page 11 data is, suppose the block 11 data is shown here. I'm going to key in 9000, press OK and hit a save. So it's over here. So I'm going to go to the counters, reduce it by 1 and say save. Oh, sorry, it is 4, 5. I think I pressed the wrong one. Yeah, the save. Now also this number is copied to block 6 here. It's not copied to the command, to the tag, sorry. And once I'm happy with everything, what I can do is I go to offline. I'm going to choose copy everything from block 0 to block 15 and start with the array cycle. It means first write the content of this block 6, the reload counter, and I'm not going to now do any locking here, but if you tick this, whatever is in here get transferred as well. Now when you hit the right, it says write grid content OK. If you look at what the software does, so the software has started with block 6 because we have ticked start with the array cycle. Then it follows from block 0, block 1, and what the software does is before it writes, it compares the data in the tag with the data on the grid. Only when those two are different, the write is done. If you look at this block 1, we have never changed the block 1. So block 1, after reading, there's no write command. It's likewise block 2, block 3. There's something the software has done it. So you don't want to write unnecessary to the tag. And you have to keep in mind these tags have a limited number of writes. You can do probably 100,000 writes for this. So likewise the block so if you look at here, the block 10 has been modified. We modified block 10. So this is a handy feature. You can use it. You can play with the tag data and you can write it. Probably if you place a different tag here, a new tag, you can transfer everything from here to the new tag by hitting this the right button. Okay, so that's all in this video. So this video showed you how to use SRI512. Thanks for watching.